pretty much this is my first time making a video, so don't judge me too hard. This is my friend Floppa Dot. It'll be good. Peace and enjoy. So this right here is a blue giant. It's a pretty sweet looking star right here. But in what stage do stars get to this, and how exactly do stars form? Well, we're about to find out. Here is primarily where stars form. It's a bunch of gas and dust all coming together, a bunch of particles that condense and later on become so tightly bound they become stars. So what we have here now is the pillars of creation. This won't be the first time our class has seen this. Thank you, Mr. Boston, who brought this to the astronomy class quite some time ago. The point of this is these are where stars form. Primarily hundreds of million stars come from these gas and dust particles and create these stars. What I'm really concerned about is how exactly stars form and what type of formations there are. So a star develops from a giant, slowly rotating cloud that is made up almost entirely of hydrogen and helium. Due to its gravitational pull, the cloud behind tends to collapse inwards, and as it shrinks, it spins more quickly. The outer part becomes a disk, while the innermost part becomes a roughly spherical clump. Now, this collapsing material grows hotter and denser, forming a ball-shaped protostar, and that's what we have here is a protostar. This is the first stage of a star. Well, I just wanted to elaborate that space.com has given me all this information, which means it is a credible source. So this is what actually happens in a star for all you naysayers out there. So as you can see right now, this is a diagram of what the evolution of stars becomes. Now you see stars have a life cycle, and as you can see here, we begin with a nebula, which shrinks, becomes warm, and later on becomes a protostar. Whoa, sweet. Then the star begins to shine as nuclear reactions occur, nuclear fission, as we were talking about in astronomy. But then there seems to be a way where it splits. You either have a supergiant or a red giant. So when one looks at the way of the supergiant, you see it's obviously a star of greater mass, and it expands, cools, and then turns red. From there, you see that the supergiant explodes, blasting away its outer layers. This is a supernova. From the supernova, then it goes two ways. Both ways, the core collapses and becomes dense. But in this case, if it were to become a neutron star, the core would become very dense and it would be a very small star. But in the case of the ultimate factor is what we human beings know as the black hole, where it completely vanishes, just outright vanishes. Everything that goes in there becomes small as a particle, and it's pretty sweet. Well, now that we saw what happened from a supergiant standpoint and the evolution from a supergiant, let's take a look back at the main sequence star and let's see what happens if things went a different way. Well, from the main sequence star, let's say that would be our sun, because that is relatively what our sun is. If it became, instead of a supergiant, it became a red giant, which is less mass but still glows the color red as it cools, let's see what line it would go down there. Well, after the red giant, it would later become a planetary nebula, which is hot to the core and will actually be exposed as a white dwarf star. Now, as this white dwarf star goes down the line and ages pass and years pass, it later becomes a white dwarf cooling star, which cools down and reddens. But primarily the big factor here is it becomes a black dwarf, which the star stops growing completely, and this is the end of the line if the sun takes a turn towards a red giant star. Now let's take a look at exactly what happens in this diagram. What this diagram presents is a jump in the evolution. Before we had, a stage set where it had to go through certain points but the main set was that everybody was going through a protostar, and the average star. But in this point, you see that the protostar can actually become anything. Well, not anything, but it can become different points of the evolution. As you can see, there's the average star, which is a sun-like star, which is what we are, obviously. It leads to a red giant, and then a planetary nebula, and later a white dwarf. So predictions look as if we're going to become our sun is going to become a white dwarf. But as you can see, you look up, across the line, and you see blue supergiants, which are the coolest stars, in my opinion, and they become supernovas, black holes, and in the long run, a stellar nursery, which performs more stars. And this is very interesting indeed, and definitely very cool.
Well, that's the end of the video. I just want to thank everybody for watching the video and staying put. Again, it was my first video, and don't judge too hard. But Strong is great. Love you guys. Mr. Boston, we miss you. Tell me how it is, Baker. Alright, out.
Standing in the rain with his head hung low, couldn't get a ticket, it was a sold out show.